skipping?
I do like a pudding thing. That's the worst holiday food. I hate pumpkin pie and I hate pumpkin pie.
Oh, I love pumpkin pie.
I eat all the time. Oh, I love pecan pie. I don't know.
My grandma makes the best.
Yeah.
There's like
Oh, pumpkin
oh
rolls.
yeah, it's like vanilla pudding. There's like whipped cream, another layer of pudding, and then another thing of whipped cream.
All right, let's take a look at number 6 here. Okay, there's a lot going on here, and it's even kind of tough to tell, I guess, what's being, like, what function is of what. So I like to add a few parentheses in here so we can see I'm taking the secant of negative 3x, tangent of negative 3x, and then here I'm taking the secant of negative 3x inside of secant squared. So what we can recognize here is that I've got secant squared of secant minus 3x. And then I've got secant of, or negative 9 times secant of negative 3x times tangent of negative 3x. So the function that I can recognize where I see a multiple of its derivative, well, if I make my u secant of negative 3x, then I've got some multiple of secant of negative 3x tangent of negative 3x. So my u here is going to be secant of negative 3x. My du then would be secant of negative 3x tangent of negative 3x times the derivative of the inside, so times negative 3. That's almost what I have here. Right? I've got negative 9 times the secant of negative 3x times the tangent of negative 3x. So we want to multiply by 3. So then we get 3 du equals exactly what we want. Negative 9 times the secant of negative 3x, tangent of negative 3x. Keep forgetting my dx. Here we go. So now I can do my u substitution. So when I do that, I will just end up with secant squared of u times 3 du. Right? Do we see that substitution? I mean, this one was ugly. There was a lot going on. But do we see how that substitution can just become this? Right, so now, what's the antiderivative of secant squared? Right, so this will just be 3 tangent of u plus c. And then plug my u back in. So 3 times the tangent of secant of negative 3x plus c. You okay with that one? What else? Did anybody get 7?
No.
Alright, let's take a look at 7. Well, I guess that is kind of the last one I want to do. Were there any others before we do 7?
You just do
5? Sure. So on this one, I can see 3x to the 4th plus 3, negative 36x cubed would be a multiple of its derivative. So if I make my u 3x to the 4th plus 3, my du would be 12x cubed dx, but I want it to be negative 36x cubed. So I would multiply both sides by negative 3. So negative 3 du equals negative 36x cubed dx. Then if I do my u substitution, I will have secant of u times tangent of u times negative 3 du. So what's the antiderivative of secant tangent? Secant. Right, so this would just be negative 3 secant of u plus c. Plug the u back in. So negative 3 times the secant plus c. You okay with that one? Anything else before 7? Alright, so on this one, we have to remember our derivatives of logs. So if I look at the inside of this cosine function, we got negative 4 plus the natural log of 4x. What's the derivative of a natural log?
Derivative over the
Yeah, so the derivative of the inside over the inside. So if I just think about taking the derivative of this piece, right, so that is going to be my u. Right? My u is going to be negative 4 plus the natural log of 4x. If I think about taking this derivative, well, that's negative 4, derivative is 0. So then the derivative of natural log of 4x would be 4 over 4x, which would just be 1 over x. That's actually what I have here, right? Dividing by x is the same as multiplying by 1 over x. So this is actually what I have, except I've got a negative 5, right? So I could have actually rewritten this as the integral of negative 5 over x times cosine of negative 4 plus the natural log of 4x. Okay, then maybe it's easier to see that we do have a function and a multiple of its derivative here. So then, we have 1 over x dx. I want it to be negative 5 over x dx again. Negative 5 over x. So I would need to multiply by negative 5. So I will end up with negative 5 du equals negative 5 over x dx. Then I can do my u substitution. So what I end up with here, I'll just end up with cosine of u times negative 5 du. So what's the antiderivative of cosine? Sine. So we'll have negative 5 sine of u plus c. And then plug the u back in. So negative 5 times the sine of negative 4 plus the natural log of 4x plus c. You okay with that one? Alright, so today then, we're just going to look at u substitution with logs and exponentials. Right, so to do that, we do need to remember derivatives of logs and exponentials. So let's start with just an exponential with a base of e and a log with a base of e. So if I say, what's the derivative of e to the u, where u is some function of x, what would that be?
To the u.
E to the u.
and then u.
Right, times u prime, the derivative of the x function. Right. Well, that's, in terms of our integral notation, u prime would be the same thing as du. Right? Du means the derivative. So we can also say this looks like this, e to the u times d. Well, what that means is, if I see something like this, and I integrate it, well, that integral would just be equal to e to the u plus c. And if you think about going backwards, if I see e to the u times the derivative of the exponent, its integral would just be e to the u. So, an example would be, I don't know, x times e to the x squared. If we think about x squared being the u, well, x is a multiple of its derivative. Right? So in something like this, when I have an exponential, generally the exponent is going to be my u.
It's funny because he like had just stopped talking right before he did it.
Here, we can take a break for you.
No, thank you.
If you guys want more pie too, you can just get up and get more pie. Well, you don't have to. Or get some water. If you want to get a cup of water, I've got cups here if you want. Or if you have a water bottle. So on an exponential, generally the exponent is going to be my u. So in this case, I would say that x squared is my u. Well then, go through the same procedure we've been doing. Take the derivative of this. So du would be 2x dx. But I just want it to be x dx. So what would I need to do? Multiply both sides by 1/2. So I would get 1/2 du equals x dx. So I can now do my u substitution. I could say this would then be the same as e. I'm sorry.
She wants to bring stuff together, so we're just throwing it away. It's like a power washer. I was gonna ignore the
I was trying so hard. Alright, so when we make our u substitution, this would become e to the u times 1/2 du. So the antiderivative of e to the u du is just e to the u plus c. Plug my u back in. My final answer would be 1/2 e to the x squared plus c.
We are not okay.
There are some things we just don't have to know. I love being so good. Matt is looking at like bloody.
Are you okay?
Yeah.
I don't understand this classroom.
The Golden Diner are going to have fun watching this.
Yeah, every time we have closer notes, she feels me to show me every single time.
First thing that she was crazy.
Alright, do we feel okay with something like this? Alright, let's.
Don't erase it. I was the coffee.
Sorry.
I need.
I got that part. I feel so sick.
I have like the headache.
How do you power the body? I did. You know what I mean? Is that their final answer?
That would be the final answer, yep.
I can't think of anything.
I think we'll all go in a high coma.
Like my stomach's like starting to cramp and starting to yeah, my stomach hurts. Anytime stomach hurts, I have some peanut butter pie. You sound like
How about something like this? 4 secant squared times e to the tangent of x dx.
Okay, u is going to be tangent.
Alright, so let's. You don't know what we did in the first problem.
I'm good.
Alright, so generally in an exponential, the exponent is our u. So we would say,
Because I know that one of these times you're going to give me a problem, I'm going to use it, and it's going to be wrong. You're like, well, I said general.
Because we can recognize a function and its derivative. It's not that bad. Well, we did examples yesterday where we had like e to the x inside of a trig function, so that would be an example where like, the exponent wasn't the u.
I don't remember, but I did one yesterday, right?
All right. So what's my du then? Secant squared. But I want it to be 4 secant squared.
Multiply it by 4.
Multiply by 4. So now we can do our u substitution. So we would just end up with
Google
squiggle line e to the u times 4 du. So what's the antiderivative of e to the u du? E to the u. So 4e to the u plus c. Plug the u back in. So 4 times e to the tangent of x plus c.
My squiggly lines are looking more like S's.
Yeah. Yeah. Well, if you plug in 1, you shouldn't have any x.
Leave that X.
And then like minus spring break. Well, actually, that's
Oh, I got the actual.
Well, all right. Now's not
Yeah.
that's time for that. Wait, what did you say? About?
I said, well, we're talking about how many days like of math and stuff I have to do.
Oh.
And I was like, well, we also have spring break, and then I said, well, I'm just going to get some extra spring break stuff.
You not. Like, I pay you not to do that.
Sharon, we are behind. Okay, we are a day behind.
We're a week
behind.
We're a week behind.
We're a week behind. We do not have time yet.
That's what I'm supposed to. I said you're on the test.
I don't want you to suffer on the UP test.
I'm going to
All right. Do we feel okay with something like this, e to the u?
I think so.
All right. This one's pretty straightforward. Okay. So let's then take a look at natural logs. All right. So if we want to take the derivative of a natural log, okay, we already mentioned this earlier. We've got the derivative of natural log of u, where u is some function of x. The derivative of that is just the derivative of the inside over the inside. Okay, u prime over u. That's the notation that we've used so far. Right, but in terms of our integral notation, we can also write it as du over u. So whenever we see something of this form, a derivative over a function. So if I take the antiderivative, oops, I wrote that backwards. If I take the antiderivative of du over u, that's going to be the natural log of the absolute value of u plus c. Okay, we touched on that a couple of weeks ago, that whenever a log ends up being the answer to an integral, we have to put absolute value bars on what's on the inside because we're not allowed to take a log of a negative number. So, an example of something like this might be, I don't know, x x plus 2 over x squared plus 4x minus 7. Okay. So in this case, we should be able to recognize that this top, the x plus 2, is a multiple of the derivative of the bottom. Right? So if I make my u x squared plus 4x minus 7, my du then, the derivative of this would be 2x plus 4. Right, but I want it to be x plus 2, so I would need to multiply by a half. So then we get what we want, 1/2 du equals x plus 2 dx. So now if I do my u substitution, I would have 1/2 du over u. So whenever we recognize du over u, that antiderivative is just natural log of u plus c. So the final step is to plug u back in. So 1/2 times the natural log of x squared plus 4x minus 7 plus c. Questions on that one? So, like, from here to here?
Yeah.
Whenever we recognize this, the derivative over the function, that antiderivative will be natural log. So the only time that this could get confusing is when we compare this to examples that we did 2 days ago with power functions, where we had, something like this. Right? If we've got something like this would not be a natural log. Right? This one we would have to use power rule on. Right? We would just have u to the negative third power du when we do this, and that antiderivative would just be negative 1/2 u to the negative second. Right? So it's only when we have a derivative over a function, okay? Not a derivative over a function to the third power or to the second power. Only when we have a derivative over a function or over the function itself.
We have to choose like
I don't want to say every time there isn't a power, but most of the time. Yeah, I mean, if we can recognize that this is just the derivative of this, there's no exponents or anything like that, then yes, most of the time that will end up being a natural law. Okay. Any other questions on this so far? Supposed to get thunderstorms.
I'm so tired. I love rain. I sleep so much better. It to rain so bad. I was just teasing. Yay! It's hard to believe before she so
It's supposed to snow here on Saturday. Is this natural still?
How about something like this? E to the x over e to the x plus 7.
So u would be e to the x plus 7.
Yeah, I mean, we should be able to kind of recognize beforehand if this fits our pattern. Like, do we have a derivative over some function? We do, right? If we make our u e to the x plus 7 by du, e to the x dx. And that's exactly what we have. So if I do my u substitution here, I didn't even have to multiply by anything. I would just end up with du over u.
So the natural log of e to the 7 plus c.
Technically, it needs to be absolute value, unless you end up with a function that would always be positive. So in this case, does e to the x plus 7 always have to be positive? It does, right? There's no way for me to get a negative value no matter what x I plug in. So in this case, we could actually just use parentheses because the absolute value of e to the x plus 7 is just equal to e to the x plus 7. Okay, but
We'll never get points
no. Okay. So yeah, it's just always safer to always use absolute value bars. Alright, you okay with that one? Alright, let's do another one of these. How about
Sure.
2x yeah, how about that? Secant squared of 2x over tangent of 2x.
Well, u is gonna be tangent to x. You sure about that? I think.
Yes, I've done a lot of that.
But use tangent of 2x.
So u would be tangent of 2x.
Du is secant squared of 2x. Times x. Wait, times 2.
Times 2. Right?
Oh, never mind.
Right? We have to remember to use chain rule here. So we would actually have times 2 here.
But you have to multiply by half.
Right, but we just want it to be 1. So I would need to multiply both sides by a half. So I would end up with 1/2 du equals secant squared of 2x dx.
Oh.
So when I do my u substitution, right, we would just have 1/2 du over u.
So.
Right.
Charged. Okay, this guy was charged over a meth sex party. Man 58 faces burger rap for checking like 69 out of nursing home and throwing a fatal bash. Didn't she ask for it though? Edmunda says a man who allegedly threw a meth-fueled death party for his alien wife has been charged with murder. She was like, I want to die, so let's go out to things. We took her out of, I think it's the same guy. Wayne Johnson. Crazy told me about.
How dare he? You could definitely see Rose when he talks to
Johnson told the police that he checked his wife out of the nursing home and medicated her with meth because she wanted to die at home. Wait, when Johnson? He medicated her with meth?
I mean,
threw her dead
if she
body
wanted to
in
die.
the nursing home.
That's what it said.
Johnson said they took the drugs, were rocking out to metal band choir ride and had sex in the hours before Deborah died. Deborah.
Alright, one last thing. Let's look at the general exponential function. Okay? All we've done is e to the u so far. So if I say a to the u, where a is any derivative of a to the u is a to the u prime times the natural log of a. Right? Technically, that's the case for e to the u as well, but the natural log of e is just 1. So, if we integrate, if we just have a to the u du, its integral would end up being a to the u over natural log of a plus c. For example, if I say, I don't know, 4x times 3 to the x squared plus 7 dx. Okay, well, I would want to make my u x squared plus 7. My du then would be 2x dx. But I want it to be 4x dx. Multiply both sides by 2. So we would get 2 du equals what we want, 4x dx. Then if I do my u substitution, I would end up with 3 to the u times 2 du. So the antiderivative here then would be 2 times 3 to the u over the natural log of 3 plus c. Okay, this is the part that gets tricky that a lot of people forget. If the base is not e, we have to divide by the natural log of the base when we're taking the antiderivative. So then the final part will be plugging my u back in. So 2 times 3 to the x squared plus 7 over the natural log of 3 plus c. Alright? Yeah. Few problems for you to do for homework.